Welcome back, everyone. This is the part 2 of our video. Let's continue then. So 6.6, calculate the average between the points A and B. So we're looking for the average between the points A and B. So how do we go about answering that one? Let's see. Point A, it's the point of intersection of F and G, right? It's the point of intersection of F and G. Perfect. But we can all see that it's also a what? An x-intercept. So you can use either f of x or g of x because it's the point of intersection. So I choose to use g. Let me just use g. So your g, you have your g of x is equals to 1 over 2 x plus 1 there minus 4. And then since this is what? An x-intercept, so which means we let y equals to 0. So this is 0 equals to 2, 1 over 2 x plus 1 minus 4. Let's try and transpose that negative 4. So now it becomes positive 4, 2, 1 over 2, and x plus 1. And then we can divide both sides by 2. Now you have your 2 equals to 1 over 2 x plus 1. And then we change this in an exponential form. So you'll have your 2 to the power negative 1. And then this is just x plus 1. And then try and remove the brackets by distributing. So you have your 2, negative x, and negative 1. So you just distribute the negative 1 there, right? And then as from there, now you have your same basis. We can now start to drop down the exponents. So this is 1. So you'll have your 1 equals to, okay, this is negative 1. Sorry for that. So minus x and minus 1, right? And then next from here, you can just transpose. So transpose 1, it becomes 2. This is negative x. Divide both sides by negative 1, and then we get negative 2. So your x is negative 2. So for point A, now you'll have your A as negative 2 is to 0. We've already got our B as 0 is to negative 3. Now let's get our average gradient. M is equals to y2 minus y1 over x2 minus x1 equals to, this is our y2, x2, y1, x1. Negative 3 minus 0 over 0 minus minus 2, which will give us minus 3 over positive 2. Then that's your final answer. So you got your average gradient as minus 3 over 2. I hope it makes sense. Let's move to 6.7. 6.7, calculate the, graph T is obtained by reflecting by reflecting G about the x-axis. Write down the range of T. Okay, cool. That's not a problem. That's not a problem to us. So T of x is equals to negative G of x. We reflect about what? X-axis, which means y should be negative. Y is our graph, which means our graph should be negative, right? But now, don't forget that the graph of G, we have a what? 2 is to half x plus 1, sorry, x plus 1 and minus 4 there, né? So we're simply distributing the negative 1 there. So you'll have minus 2, 1 over 2x plus 1, negative times negative, that's plus 4, right? And they are looking for the range. So now we can say, therefore, we are simply focusing on this. So the range would be, where do we see our graph? In terms of what? Of y, which means we need to focus on our y. So y is an element of negative infinity is to positive 4. That's where we see our graph. Or you can say y is less than 4. So this was 6.7. This was 6.7. Now let's go to 6.8. 6.8. If p of x is equals to f of x plus 2, write down the coordinates of turning point of p. Okay. So your p of x is equals to your f of x plus 2. But what is our f of x? Minus x minus 3 squared plus 25, right? Okay, and then, okay, let me use a different color here so that things can be clear to you. So you have a what? Plus 2 plus 2. Now, let's continue. 25 plus 2, that's 27. So now the turning point of P from this would be 3 is to 27. So it would be what? 3 is to 27. So this is our new turning point of P. Correct. Now let's move to 6.9. 6.9, let me try and create some spacing. So for 6.9, here they are saying determine the value of k for which the straight line y equals to 2x plus k will be a tangent to f. Okay, it will be a tangent to f. Tangent to f. Let's go back to the basics. This is your parabola, and then this is your straight line, which becomes your what? Your tangent, for an example. Now, there's one thing that you should know about these two graphs. If you have a tangent and a parabola, then their delta is equals to 0. Not just any delta, but the delta of the parabola and the what? The straight line. Because here, when they touch, that becomes the point of intersection, which means we must equate the graphs and get the delta of the parabola and the straight line. So that's the first thing, right? So for 6.9, you have your f of x there equals to negative x minus 3 all squared plus 25. You open to bracket, apply the FOIL method, and then we get to this step, right? When we use the FOIL method, we're trying to simplify this, right? And then after that, now we are saying, since this is the point of intersection, which means we must equate both graphs, right? So you have your minus x squared plus 6x plus 16 equals to 2x plus k, tangent and the what? The parabola. Now let's transpose everything to the left-hand side. So you have your minus x squared, 6 minus 2, that's positive 4x. And then we have 16 minus k equals to 0. And then from here, the value of a is the coefficient of x squared, that's negative 1. Value of b is equals to 4, that's the coefficient of x, and then constant becomes c, right? Now, we need to have our discriminant equals to 0 from this information. So b squared minus 4ac equals to 0. But what is our b? Our b, that's 4 minus, okay, 4 squared minus 4, our a, you have your negative 1 there, and then you c, that's 16 minus k equals to 0. And then 4 squared, that's 16, which gives us 64 minus 4k. So you multiply these two, you get positive 4, and then positive 4 times 16, that's positive 64, right? And then positive 4 again times negative k, that's negative 4k, then equals to 0. And then from here, we collect the items and then we add them. 16 plus 64, that's 80. We transpose, we have 4k, divide both sides by 4. Therefore, your k is equals to 20. You are looking for the value of k. So guys, I believe that this makes sense to everyone. Thank you so much, family, for your time and for watching my YouTube videos. This is the end of our session. Bye.